So here we have another question from Work, Energy and Power. This is June 2019, question 12. Machines work easier by changing the size or direction of a force. A student designed a simple machine to lift a box of mass 50 kg. The student claimed that the efficiency of the machine was greater than 90%. The machine used a slope of height 2 meters and length 15 meters to move the box. The box was connected to an 8 kg mass by a rope over a pulley as shown. As the 8 kg mass fell, the box moved up the slope at a steady speed. Steady speed can also mean at a constant speed as well. Okay. Now we have to see if the efficiency of the machine was greater than 90%. So this is the machine right over here. This entire system is the machine. Okay, so remember our aim, what we're looking for, our output is going to be the 50 kg box moving up. Okay, and our input, the reason for the box moving up is because this machine right here falls down. It loses GPE as it falls down. So as it loses GPE, that energy has to go somewhere else. So some of that energy a lot of that energy is going to make this 50 kg box to move up. Okay, so the energy from this, some of it will be transferred to this. So the GPE that this loses, some of it will go to this, or a lot of it will go to this 50 kg box for it to move up. Okay, so first let's calculate the energy gained by the box. So we're going to calculate the energy gained by a box, which is going to be the output basically. So one very, very, very important thing to understand this question is when the box is here, from here to here the box will, or not the box, the machine will fall down. So it's going to fall from position A to position B, and it's going to cover a distance of 2 meters. Clear? I think we're fine with that. Now notice this mass here, this 50 kg mass or this 50 kg box that's there. Initially the box would be somewhere here. Okay? This box also will move a distance of 2 meters. Okay? The box, 50 kg box also moves a distance in this direction of 2 meters. Because this machine here falls a distance of 2 meters. It's kind of simultaneous. As this falls 2 meters, this goes up parallel to the plane by 2 meters. That's a very important point. This 15 here is given to trick you. Okay? It has a purpose to find this angle theta, but it's not for you to use in your work energy formula. Okay? So energy gained by box will be force times distance. Now remember I told you that the speed is constant, which means that this force here, the tension force here, should be equal to the force that's acting down, which should be mg sine theta. So I'm going to put in mg sine theta times distance of 2 meters. It moves a distance of 2 meters and then it stops. Okay, and then I'm not sure what's going to happen. Given the context, it only moves 2 meters. Okay, this force is equal to mg sine theta. This force here is actually the tension force that's there. Okay, so now we know this is going to be 50 g sine theta. So how do we find sine theta? So we can do the right angle triangle. We have theta, we have 2, we have 15. Now this is where that 15 comes into use. I can say sine theta is O divided by H. So I'm going to say 2 divided by 15 times 2. Okay, so that's going to be the output, the output we're getting. Okay, that's the aim. The thing that we want our system to do is to lift that 50 kg box up. Okay, and the reason that 50 kg box is moving up is because of that input, and that energy. So that input is the energy lost by the machine, which is going to be equals to the m, g and h. So that's going to be 8g times 2. So let's find both the values out. So where I get both the values is the output, this is the input. So I'm going to divide both the answers. So energy output divided by energy input times 100. Let's see what we get. So the answer is going to be 83.3%, and that is actually going to be less than 90%. So the maximum efficiency of the machine was not greater than 90%, not greater than 90%. So that's your answer.